Okay, so for part 2 of our module 3, instrumentation, we will begin with Beer's law. So Beer's law yung ating formula or yung sinusunod natin sa pagko-compute ng concentrations ng ating analytes na mini-measure sa laboratory. So Beer's law states that the concentrations of the unknown substance, ito yung mga sample natin, is directly proportional to the absorbed light. So yung absorbed light yung nakukuha sa ating machine or yung binabasa na ng ating machine. So it is inversely proportional to the amount of transmitted light. So yung transmitted light, yung light na dadaan sa sample, then magkakaroon ng computation, magiging siyang absorbed light. So yung machine na ang nagko-compute nito, pero if manual yung ating spectrophotometer or yung semi-automated, tayo yung magko-compute nito. So ngayon medyo automated na, so sila na yung nagko-compute nun, machines na. Ang ginagawa na lang natin is mag-feed ng sample, tapos i-check kung okay yung pagkakaroon niya. Next, so mathematically established the relationship between concentration of and absorbances. So sa formula nito, ang ginagamit is concentration of unknown and the substance or the standard, and the absorbance of the unknown and absorbance of the standard. Simulan natin sa percent transmittance. So percent transmittance is the ratio of the radiant energy transmitted divided by the radiant incident on the sample. So yung radiant energy transmitted, yung T, ito yung light na dumaan na sa sample. Ito namang radiant incident on the sample, yung light na galing sa ating light source papunta sa sample. So ito muna pupunta sa sample. So radiant energy from light source, pupunta siya sa sample. After pumunta sa sample, magiging siyang transmitted light. Transmitted light, i-compute or kukomputin ng machine. So transmitted light or percent transmittance is measured by the spectrophotometers to derive the concentration of the unknown. Concentration of the unknown, ito yung sa ating analytes or yung sa ating substance na mini-measure. So paano ang formula ng percent transmittance? Ang kanyang formula is percent T or malaking T, percent transmittance, equals I sub T over I sub O times 100 para siya maging percentage. Whereas I sub T is transmitted light through the sample, yung dumaan na sa sample. I sub O is intensity of the light striking the sample. So yung light from the light source papunta sa sample para siya maging transmitted light. In the actual practice, light transmitted by a blank is substituted for I sub O. So ito, I sub O, pinapalitan natin ng transmitted light na dumaan sa blank. So ano ba yung blank? Ito yung distilled water lang yung nilalagay natin para matanggal natin yung kanyang interference sa container or yung ating cuvettes, yung pinaglalagyan ng sample na mini-measure natin bago natin siya i-run or yung parang nilaran natin. Halimbawa dito ay yung tubes natin na ginagamit sa pag-run. Pero pag manual yung atin, pwede tayong gumamit na glass tubes yung manual. Pero din namang mga cuvettes or yung specific na siya sa machine. Depende kung ano yung brand at model ng machine natin, yung ginagamit niya na cuvette. Okay. So, percent transmittance, ganito yung itsura niya or yung para kanyang yung sinusunod natin. So, incident light papunta sa sample. Ito yung sample natin. Tapos, transmitted light. Ito yung ating readout device. So, kukompute na lang siya. Pwede natin or pwede na machine. Ito yung tinatawag natin na sample beam or yung blank beam pala. Blank beam signal. So, yung incident light pupunta sa blank, tapos gagamitin natin to para sa blank beam signal, para dito sa lalagyan niya. Kasi itong lalagyan, magkakaroon pa din niya ng konting interference sa ating readout or sa ating measurement. So, para mawala yun, ginagamit natin ng blank. So, sa to ay sa blank lang. Then, yung sample naman, feed natin. So, same na lalagyan para siya ng type ng lalagyan or ng cuvette. Tapos, measurement, tapos i-calculate na siya. Sample beam signal, yung sa sample, tapos blank beam over blank beam signal times 100 para makuha mo yung kanyang percent transmittance. So, ginagamit natin yung percent transmittance para makuha ang absorbance. So, dito yung kanyang formula. Ano muna yung absorbance? So, absorbance is the amount of light absorbed. Yung light na na-absorb ng ating substances. So, it is inverse logarithm of the transmittance or yung percent transmittance. So, ika-calculate natin para makuha yung absorbance. So, absorbance cannot be directly measured by the spectrophotometer kasi parang derived siya or kinakalculate from the percent transmittance. So, ito nga. Absorbance is mathematically derived from percent transmittance. So, absorbance equals ABC or equals 2 minus log percent transmittance. So, percent transmittance, yung na-compute natin kanina. Then, i-compute mo siya sa scientific calculator. 2 minus log percent transmittance. So, ang lalagay mo lang is 2 minus log tapos yung percent transmittance na. So, Beer's law. So, sa Beer's law, ang ginagamit natin is dalawang concentration and dalawang absorbance. Since hindi natin alam yung concentration ng unknown, ginagamit natin yung Beer's law para mag-derive tayo ng formula para makuha ang ating concentration of unknown. So, paano yun? Ililipat natin yung CS sa kabila. So, ito ay eta times dito. So, parang ganito. Concentration of the unknown equals absorbance of unknown times concentration of substance or standard divided by absorbance of standard. So, standards yung na-discuss natin dati. Known yung concentration niya, i-measure lang natin yung absorbance para may relate natin dito sa concentration of unknown. Pwede din naman ang pagko-compute niya, concentration of unknown equals absorbance of unknown divided by absorbance of standard times concentration of standard. So, depende sa inyo. Basta rule of math lang yan. Pwede muna to, tapos divide. Or pwede namang dito, divide muna, tapos times. So, ano yung CU? CU is the concentration of unknown. CS is the concentration of the standard. AU, absorbance of unknown. AS, absorbance of standard. So, lahat ng A, mini-measure natin. Yung concentration of standard, alam na natin, nasa insert yan. Titingnan nyo na lang sa insert kung ano yung concentration ng standard. Then, concentration of unknown, ito yung kakalculate natin. So, yung sa standard, pwede itong iset na natin after natin mag-calibrate ng machine or ng equipment. Pagkatapos natin mag-calibrate, pwedeng nakasave na siya doon. Tapos, ang i-measure na lang natin lagi is absorbance of unknown. Tapos, automatic, ika-calculate na lang siya sa absorbance of standard para makuha natin yung concentration of the unknown. So, blanking techniques. So, blanking techniques are used to correct for artifactual absorbance readings. So, dalawa yan. Pwedeng reagent, pwedeng sample blank. So, yung reagent blank natin corrects the absorbance caused by the color of the reagent. So, yung color ng reagent ang ating kinokorek dito. So, ito yung the absorbance of reagent is also automatically subtracted from each of the unknown reading. So, yung pinagsasama lang dito is yung reagent lang tsaka yung ating cuvette. Tapos, i-measure para matanggal natin yung interference absorbance ng color ng ating reagents. Next, sample blank. So, sample blank measures absorbance of the sample and reagent in absence of the end product. So, pwede kasing yung reagent natin, 2 parts o pwedeng dalawa yung reagent na nilalagay natin. So, yung unang reagent, yung kanyang parang buffer lang. Then, next is the end product or yung color developer. Para makita mo yung nangyaring reaction sa sample tsaka sa ating reagents. So, usually, pag magsa-sample blank, ang sinalagay lang is yung sample, then your agent. Wala pa yung color developer. So, this corrects the measurement for optical interferences like hemoglobin, absorbing the wavelength of the measurement. So, para pag may interference na hemoglobin, natatanggal natin siya. Though, yung hemoglobin kasi galing kapag hemolyzed yung sample natin. So, kapag hemolyzed, madami talaga siyang interference sa mga samples, sa mga test natin. Kaya, usually, hindi na natin siya ginagamit if interference yung hemoglobin. Nagre-recollect na lang tayo ng bagong sample. So, sample blank is ineffective in cases of turbidity due to lipemia. So, hindi siya maganda or hindi siya ginagamit for lipemia. Usually for hemoglobin lang. So, para sa lipemic samples or yung madaming taba, ultracentrifugation may be necessary to clear the serum or plasma of kilomicrons. Ito yung mga fat natin. So, reagent blank corrects absorbance caused by the color of reagents. Then, sample blank corrects the measurement of optical interferences like hemoglobin. Okay, so next principle natin sa ating clinical chemistry is the flame atomic emission photometry. Flame or atomic emission photometry. So it measures the light emitted by a single atom burnt in a flame. So yung light after natin i-expose sa flame yung atom, kung ano yung light na may i-produce niya after siya maging single atom na. So used for the measurement of excited ions like sodium and potassium. So ang ating internal standard na ginagamit is lithium and cesium. So lithium and cesium corrects variations in flame and atomizer characteristics. So anong principle natin nito? So substances are exposed to high temperature results in excited atoms. So na-excite na siya or parang nagkaka-charge, which almost immediately return to ground state after giving off energy of a specific wavelength. Excitation of electrons from lower to higher energy state. So the concentration of the substance is directly proportional to the amount of light produced. So kung ano yung light na i-produce niya after natin siya expose sa high temperature, yun yung measurement ng ating substance para siyang directly proportional. So anong ating components ng flame or atomic emission photometry? Pwede din siyang FEP. Number 1, gas. So ito yung source of flame natin para natin siya ma-expose sa high na temperature. So mixture of hydrogen and oxygen or natural gas, acetylene and propane in conjunction with air and oxygen. So flame temperature should be held constant. So dapat constant siya para hindi tayo magkakaroon ng variations sa kanyang charge na binigay natin or kanyang excitation. Number 2 is the atomizer or the burner. So this introduces heat to atoms. Ito yung maglalagay ng sample sa ating atomizer, sa ating flame. So light source. So light source is each element produces an individual characteristic wavelength. So kapag sodium, color yellow, potassium, violet, magnesium, blue, lithium and rubidium, red. Next part is the entrance slit. So, kagaya ng ating mga slits dati, kung para papasok, para makontrol natin yung light na papasok, then yung exit slit, control yung light palabas. Monochromator isolates the specific wavelength of interest. Then, detector. Yung detector natin requires water and standards to establish thermal equilibrium before measurement. So, yung detector natin yung pang-measure ng light emitted ng ating samples after excitation. Internal standards. So internal standards provide a point of reference or reference point in sample, control, and standards. So they correct the variations in flame and atomizer characteristics. They minimize the effect of changes in flame, temperature, and aspiration rate. Acts as a radiation buffer to reduce the effect of mutual excitation. So para siyang control or para makontrol natin yung environment, yung ating standards. So saan natin ginagamit yon? For sodium and potassium measurement, lithium and cesium yung ating standard. For lithium measurement, potassium and cesium yung ating standard. So flickering light indicates changes in field reading of the instrument and it is not routinely used. Okay, next is spectrophotometry is the atomic absorption spectrophotometry. So it measures the light absorbed by the atoms. Yung kanina, mina-measure niya is light emitted by a single atom burnt in a flame. So, yung single atom, light emitted. Yung light na puproduce niya after natin siya i-excite. So, ito yung mga tatandaan niya, yung ano yung mine-measure niya, principle niya, saka siya ginagamit. So, Atomic Absorption Spectrophotometry or AAS. So, saan nga? Light absorbed by the atom, dissociated by heat. Yun yung konting pinagkaiba niya. So, used for the measurement of unexcited trace minerals like calcium and magnesium. Its principle is the measures the amount of light absorbed by the element or the sample in an unexcited state or unionized state or its neutral atom, ground state, and dissociated from its chemical bond. So ground state atoms absorb light at defined wavelengths. So measures light absorbed by ground state atoms. So inversely proportional siya sa flame photometry since after the flame dissociates, the element forms chemical bonds, then the atom remains in the ground state. And the amount of light absorbed is measured rather than emitted. So para sa yun una nating spectrophotometry. Yung light absorbed, yung measure, tapos yun yung ating i-compute, hindi yung light na ina-emit niya. Kasi wala siyang i-emit, kailangan yung light absorbed niya. So AAS is more sensitive than FEP, used to detect small amounts of metals, heavy metals and trace elements, and it is the reference method for calcium. So phosphates would interfere, so lanthanum or strontium are used as diluents to bind the phosphorus. So magka-partner kasi yun calcium tsaka phosphorus. So para matanggal natin yung phosphorus as interference, ibabind or ibabond natin siya sa lanthanum or sa strontium. Operation or paano yung principle niya? Yung process pala. So sample is atomized in a flame. So may atomizer din yan. So atoms of the metals to be quantified are maintained at ground state. Nasa ground state lang siya, hindi excited. Beam of light from hollow cathode lamp, HCl, is passed through the chopper to the flame. The ground state atoms in the flame absorb the same wavelength of or from the hollowed cathode lamp. Light absorbed by the atom is measured as decrease in light intensity by the detector. So yung light absorbed, yung i-measure natin siya. So pag nagbaba yung kanyang transmitted light, kasi nagkaroon ng light absorbed, yun yung ating mini-measure, parang yun na una. So difference of light leaving the hollow cathode lamp and the amount of light measured by the detector is directly proportional to the concentration of the analyte. So for example, yung ating light is 100. Then, yung ating light absorbed is 30. So ima-minus natin yun. So 70, tapos yun na yung kukumputin para makuha yung concentration of the analyte. Iba yung kanyang measurements na nakukuha, hindi siya bastang yung 100 tsaka yung 70. Makikita nyo to pag nag-process na kayo ng samples sa ating manual or semi-automated na spectrophotometer. So components of our atomic absorption spectrophotometer is number 1, hollow cathode lamp. Siya yung source of radiation. Then filter gas such as neon or argon yung placed inside the lamp. So siya yung nagpo-produce ng ilaw. Number 2, nebulizer or atomizer. So sprays the sample into the flame and used to convert ions into atoms. Chopper, used to modulate the light source. Monochromator, syempre, to isolate light by filtering out exogenous energy from the flame. So para makuha lang natin yung specific wavelength na kailangan natin. Number 5, slits. So entrance and exit slits. Detector. So detector measures the intensity of light energy produced from the monochromator. Usually, a photomultiplier tube yung ginagamit. Then internal standards is not needed kasi changes in aspiration have little effect on the number of ground atoms. Interferences niya, chemical. Kapag flame cannot dissociate the samples. Ionization, it is when the sample in the flame becomes excited, so nakaka-interfere siya sa ating measurement. Matrix, when light absorption is enhanced by organic substance, or when the sample is evaporated in the flame and produces a solid particle. Okay, so next is magbibigay ako ng video para dun sa mga yan, para makita nyo yung process kung paano siya ginagawa. Another atin kanina ay colorimetric. Next is volumetric or TITRIMETRIC. So the sample or known sample is made to react with a known solution in the presence of an indicator. So ano yung ating ginawa na ganun? Yung color violet. Nagva-violet siya kapag sumobra. Yung parang pink to violet yung color na unti-unting dinadagdag para makuha natin yung concentration. Pag sumobra, color violet na siya or yung color pink na matingkad na hindi nawawala. Ibig sabihin, sumobra yung measurement natin, uulitin na yon. So, ano yung tawag natin doon? Yun yung burette. Okay, so examples ng ating volumetric or TITRIMETRIC is Shales and Shales method for chloride and EDTA titration for calcium. Another one is our turbidimetry. So turbidimetry measures the amount of light reduced or blocked by particle formulation. So yung amount ng light na mabablock mo, yun yung ating mini-measure sa turbidimetry. The turbidimetry determines the amount of light blocked by a particulate matter in a turbid solution. So the measurement of reduced light is due to the particle formation sa ating sample. So pag nagkaroon ng particles, mabablock niya yung light. So yun yung ating mini-measure, yung blocked light. Specimen concentration is directly proportional to the amount of light blocked, which depends on the specimen concentration and particle size. So tandaan nyo kung alin dito yung mga directly proportional at indirectly proportional. Solutions requiring quantitation by turbidimetry are measured using visible photometers or visible spectrophotometers. So saan siya ginagamit? So ginagamit natin siya for the detection of bacterial growth in broth cultures, antibiotic sensitivity tests, coagulation studies, protein measurement, and CSF and urine. So itong last is sa chemistry, coagulation ay sa hema, itong first two is sa microbiology. Next is NEPHELOMETRY. So NEPHELOMETRY measures the amount of light scattered by a particular solution. Yung turbidimetry, amount of light blocked. Ito, amount of light scattered. So amount of light scattered is directly proportional to the number and size of particles in the solution. Light scattered is measured at an angles of 15 to 90 degrees of the cuvette. For forward scatters, ito yung for larger molecules. So used for the measurement of large particles like antigen and antibody complexes, so saan yung mga yun? Ginagamit siya sa ating serology. Components. So number 1 is the light source. So syempre kailangan may light kung saan natin imabawas yung or manggagaling yung yung kanyang reflected light. So una is light source, mercury arc lamp, tungsten filament lamp, pwedeng LED or laser. Collimator, a device that produces a beam of parallel rays. So yung pang-control kung saan pupunta yung light. Monochromator, para makuha natin yung specific wavelength. Cuvette, siya yung lalagyan ng ating sample. Stray light trap, kapag may light galing sa labas, kailangan nating kontrolin yun para hindi siya makasama sa ating measurement. Kasi pagka nagkaroon ng light galing sa labas, again, interference na yun. Last is the photo detector. Ito yung ating pan-detect ng scattered light at pang-measure na din. So note, sensitivity depends on the absorbance on the absence of background scattered from scratch cuvettes and particulates from the reagents. So used measures from antigen and antibody complexes. So ito muna yung part 2. Then sa part 3 yung iba pang ating principles sa ating clinical chemistry. Thank you.